Hi. Yes, so we've talked a lot about energy so far, and Rob asked if I could maybe see whether there were links and whether DfP could help deliver indoor environmental quality as well. So this is not specifically about design for performance, but certainly a lot about the principles and how they might help. So what I'm exploring here is whether there is evidence about links between low energy buildings and good indoor environmental quality. And very much in the industry, they are the sort of simplistic extreme ends where either there are sometimes dubious claims that green means healthy, means productive people, and the other end is that there's an absolute conflict and it's energy versus environmental quality or health. So my personal opinion is that common sense says they should be. Obviously, there are potential areas such as ventilation rates or filters where we might have to compromise, and I'll come on to some of these. But overall, a lot of the things that Sarah and Rob were talking about should also lead to better environmental quality, including comfort and air quality. So good design and processes, good handover and commissioning, good operation and maintenance, monitoring of what's happening in the building, all of these in theory should help, and focusing on in-use performance as opposed to compliance. More specifically on the design, the sort of modeling and design processes that Rob was talking about, certainly one would think is also helpful for environmental quality, whether it's comfort or air quality. Once you have gone through the process of understanding how a building works, how people might use it, what the hours of operation might be, likely occupancy rates, as opposed to compliance-based, you're not far off from a thermal comfort model, which, by the way, will be much easier to sell to your clients if you're offering a whole package. I don't know if you've ever tried to sell a £40,000 fee for a model on the basis of potential energy consumption savings. But it's much easier if you say, we'll also do your thermal comfort and potentially a bit of air quality. And I think you can already see that in some performance contracts that actually look at both already and that are starting to guarantee both energy performance and thermal comfort or user satisfaction. We don't have that many in the UK, but there are certainly some. Passive House has some aspects of it. Neighbours has modules on environmental quality, and there are some companies, both in the UK and on the continent, that do that for big public sector clients already. Basically understanding how the building is going to work. But is there actual evidence of the links? Well, unfortunately, there's not that much. First of all, because there's not that much reliable energy data. And a lot of the claims around energy, low energy buildings and environmental quality are sometimes dubious, again, because they rely on, say, the building being green because it had a LEED certificate or a BREEAM certificate. And I'm sure you have seen many articles about this. So studies are actually based very clearly on the link between energy consumption and indoor environment are actually quite rare. One of them is Neighbours. So they have, and this is simplistic, but they have analyzed the indoor environmental ratings against the energy ratings. So I'm going to move away from the graph, no, if I can. So on this graph, the more to the right is the better energy performance. Green bars are also good environmental quality. Gray bars are bad. So you might be able to conclude that the better energy performance buildings also seem to tend to have better environmental quality, indoor environmental quality. There's also, so that's my analysis, but based on Innovate UK data, the big non-domestic building performance evaluation program of a few years ago. So overall, there is a very, very loose trend but clearly not that tight between user satisfaction overall and user comfort and energy consumption. So low energy buildings, good user feedback. High energy building, poor user feedback. Very, very loose trend. One of the problems in that, obviously, is that it's based on user feedback as opposed to data. And that leads me to a big issue at the moment that we have when we talk about designing for performance and indoor environmental quality, in that that is not very well defined. So I'm going to simplistically assume at the moment that thermal comfort, we have sort of sorted the criteria. I know they are evolving, there's still debate around it, but we have a lot of guidance from CIBSE, ASHRAE, and other organizations about different criteria that can be adapted. Lighting, I'm not even going to attempt to mention that because there's such a big debate at the moment around lighting and health that I'm more than happy to take that at Q&As, but not here. So I'll focus on air quality. The problem at the moment is that when results report air quality, they actually very often just rely on proxies. So either user feedback, by which they mean people were happy, they didn't complain that it was stuffy, or design measures. What they meant was, oh, we had high ventilation rates. Or indicators such as VOCs, total VOC levels, CO2 levels, or human outcomes, let's say, so perceived productivity or measured in some form, which we'll come to. And these proxies all have obvious problems. User feedback might be good in terms of satisfaction, but it's not at all an indicator of real air quality. The obvious examples is carbon monoxide. People don't notice it, no one might complain, you might die from it. Relying on design measures, again, an obvious example of why that's not a real indicator of air quality is outdoor air pollution. You might have very high ventilation rates, but no filter, which means you will still have poor quality indoors. Indicators such as VOCs or CO2 or humidity, they're actually okay to a certain extent if you're quite clear on what your indoor pollutants might be, but they won't cover everything. And human outcomes such as productivity, the big question is how you assess that. Therefore, it's quite difficult to, at the moment, trust a lot of the studies. And here are my tips. So they're not official CIBSE tips, but if you do see studies that claim a link between indoor environmental quality and the performance of people or their productivity, I think key things to look at is when we talk about cognitive performance or productivity. Are you talking about some individuals in the study or the whole organization? And if it's the whole organization, is it very bespoke metric to that organization? For example, factory output or sales turnover? Or is it HR metrics? There's laws being developed, but there's no real consensus at the moment on how data is reported. A lot of the studies are also based on tests. Some of them are reasonably bespoke and appropriate, others are not for the organizations being looked at. Is there a control group? So I'm sure you've seen loads of studies where you change a parameter, people are much happier, they're so much more productive, it's wonderful. However, there's a lot of evidence that this happens a lot of the time if there is change of some sort. The question is there another change? And have you tested against another change that might also have had an effect on productivity that is not related to your environmental quality factor? Is the change sustained over time? We're all happy when we move to a new building that is a bit less rubbish than our previous one, but is it going to have a long-term effect? And then on indoor and environmental quality factors, again, are you actually assessing your productivity against a known factor that is likely to have an impact on people? Or is it some form of umbrella term or design measures? There's a lot of studies that report about daylight or views out and the impact. What did you mean by daylight? What are the lux factors? Where are they measured? How do you actually measure that this has had an influence on the environment of your people. A view out, it might be that you're talking about light in terms of benefits. It might be that people now have a view of a tree, and that's what makes them happier or more productive or whatever. So this is a long way to say beware of the studies. And I personally would really recommend a particular one by Osland and Burton from 2012. They actually have a more recent one, but this is very similar. And what they did is essentially a peer review of all these studies, and they sort of weight them according to how many people are in the sample, how reliable the data seem to be, whether the tasks being assessed in terms of productivity were representative. A lot of the studies look at performance against one task, but it's actually something that workers might just do for 1 hour of the day, so it's not really representative of their own performance overall, and certainly not of the organization. And basically what it means is that you end up moving from big headlines that you have all seen in various reports that I will not name about potential 30% improvement in performance of your workers to something at an organization level that might be between 1 and 3.5, depending on whether you're looking at lighting, temperature, ventilation, space arrangements. Now, it seems small. It's actually pretty big at an organization level, that sort of improvement. But I think that study puts a lot of science behind the noise. Going back to another of the issues at the moment in the conversation around performance and indoor environmental quality, as I said, a lot of the time we talk about design measures as opposed to design outcomes. And in particular, we do that with ventilation rates. And this is one thing that at the moment Neighbours does. So the indoor environmental quality module talks about ventilation rates with CO2 in mind. And it has criteria for other pollutants, but they're just defined in relation to the average Australian building, whatever that is, as opposed to clear science, health-based targets. We're even worse in building regulations. So our building regulations only say there shall be adequate ventilation. Adequate is not defined, and it only talks about ventilation. Someone at some point seems to have realized that this might not be enough. So all they've said is, it is assumed that the outside air is of reasonable quality. So building regulations officially don't look at indoor air quality, they just look at ventilation. Thankfully, a review of Part F has been announced, so hopefully that will change soon. One big exception in the general approach is the Well Building Standard, who really was the first big standard organization to put clear indoor air quality targets that are linked to the WHO. They're not quite aligned with the World Health Organization, but they're at least informed by it. That was a big change. The other big change, obviously, is that they're measured in operation. And from my experience, that has been quite influential on many projects. Very quickly, so the upcoming CIBSE guidance on health and well-being is informed by all of that. And so what we're trying to do is move away from guidance that is based on design measures, perceptions, satisfactions, indicators, to clear desired outcomes in terms of indoor environmental quality, using health-based metrics where they exist, and pollutants as opposed to indicators. And this is very broadly aligned with a lot of emerging guidance, for example, by NICE, by Public Health England, and by ISO. Which means that if we look at indoor air quality, we end up with essentially CIBSE guidance that would be based on the WHO and also on regulations, where regulations exist, to have a clear target, although with a lot of caveats, because sometimes the science doesn't exist, or some people might be more sensitive than others, etc., etc. It does become quite complex. You understand why engineers prefer just ventilation rates. And in terms of comfort, always emphasizing that actually flexibility is valuable in itself, and user control is highly, highly valued. To illustrate the fact that it becomes complex and that engineers would love to stick to ventilation rates, just picking 2 pollutants. If we look at the guidance around, there's basically no consistency whatsoever between the various regulations, standards, certificates, whether they're more or less onerous than the WHO, whether the UK is aligned with Europe. Let's not even go there. So what we will do, obviously, is keep giving design guidance, but having provided that background on why, basically. I'll wrap up quickly. I just want to finish on one of the big debates about energy efficiency and health, and it's about CO2 levels, particularly in offices. So traditionally, and that is still the advice of public health specialists, CO2, unless it's at very high level, is not a pollutant. It's an indicator. And in most cases, ultimately, it's just used as a measure of ventilation effectiveness against indoor human-generated pollutants. And that is obviously where there are clear links with energy efficiency, because CO2 levels can vary so much in various rooms that if you have that sort of control that links it to ventilation, you can save on ventilation as well as provide more when you need it. And that is certainly my experience on projects that followed DfP and the well building standard, that it generated a lot of energy savings as well as improvements in ventilation. However, you probably all have heard about a recent study by Harvard, so it's Harvard, so it sounds good. And there were a lot of headlines in the paper about offices making you unproductive, pilots losing their decision-making powers, etc., etc. And to be fair to that study, it is one of the better ones. They've actually been quite thorough. So, for example, they looked at the impact of CO2 levels very clearly independently from ventilation rate. So they injected CO2 into the airstream, but keeping the same ventilation rate to try to separate different factors, etc. And they had a sample of 24 people only over essentially 2 weeks. And they tested them every single day for their decision-making capacity. So again, reasonably robust tests, not the sort of how many calls a minute or how many letters a minute do you manage to type. And what it shows is quite dramatic. So when you increase CO2 levels, most indicators of our decision-making capabilities get worse. Not all, by the way, but most. However, the current guidance, more or less between BS, high quality or medium quality, and the well building standard is in that blue band. So actually, a lot of this zone where our pilots are going to crash our plane are in areas that are already not recommended by good practice guidance. So what I would say is that this just, again, as if we needed that additional study, reinforces the need for better commissioning of buildings in the first place, and then monitoring, operation, and maintenance. There might be some gains in the margins, but I think compared to the bigger picture, broadly speaking, the guidance aligns on both topics. Thank you.